Welcome. In this video, we will talk about the HeapSort algorithm, and how to sort an array of numbers using this process. First, let's define what HeapSort is. HeapSort is an algorithm that sorts an array of numbers in order, that array being formatted first as a heap. But what is a heap? A heap stores data in a complete binary tree, such that all the children of a parent are either less than or greater than itself. Now, let's try to construct a valid heap tree using this example. Let us construct a heap for the list 4, 7, 8, 5, and 3 using a binary tree. For a node located at index I, its left child is found at index 2i plus 1, while its right child is at index 2i plus 2. So from this list, we would be able to generate this tree, but it is not valid. To make it a valid heap, let us start with the rightmost node on the second level. But the third node, which is 8, has no children, so we move on to the node on its left, which is 7. We check if either of its two children, which is 5 and 3, is greater than 7. The nodes on the second and third level are already valid, and so we move on to the root, which is 4, and check its child nodes, 7 and 8. 8 is greater than 4, and so we exchange the two. As you can see, all the parent nodes are now greater than their child nodes. Now let's try the heap bottom-up algorithm to construct a heap using the same example. I gets the floor of n over 2, which is 5 over 2, is equal to 2. K gets I, which is 2. V gets the number on index k, which is 7. And heap gets false. While not heap, and 2 times k is less than or equal to n. Or not heap, and 2 times 2 is less than or equal to 5, which is true in our example. J gets 2 times k, or 2 times 2, which is 4. Next, we check if j is less than n, which is true in our case. And we check if index j has a value less than the value of index j plus 1. In our example, 5 is not less than 3, so we skip and move on to check if v is greater than or equal to index j, which is also true in our case. Therefore, heap gets true, and index k gets v. We go back to the while statement and check if our values satisfy the statement. Currently it is false, so we terminate the while loop and return to the for loop. I gets a new value of 1, and k gets the value of I, and v gets index k, which is 4. Also, heap gets false. While not heap, and 2 times 1 is less than or equal to n, j gets a new value of 2. Check if j is less than n, which is true. And if index j is less than index j plus 1, or in our case if 7 is less than 8, which is also true. Therefore, j gets a new value of 3. Next, we check if v is greater than index j, or if 4 is greater than 8, which is false. Therefore, we move on, and index k gets the value of index j, and k gets j, and index k gets the value of v. We go back to the while statement and check again if the statement could be satisfied. While not heap, true, and 2 times 3 is less than or equal to 5, which is false. We terminate the while loop and terminate the for loop, therefore stopping the whole simulation. Here, we see the same answer as the one we did using the binary tree. But as you have may noticed, the array is still not in ascending order. That is because this is just the first part of the HeapSort algorithm. Next, we will go on to part 2, where we will learn how to sort a heap. First, we exchange the root node with the last node and remove it from the tree. And then we arrange it from top to bottom, to make it a valid heap tree. We exchange 3 and 7. And exchange 3 and 5. And then repeat the exchange between the root node and the last node, then delete the last node from the tree. This process will be repeated until there is no node left. And there you have it. A sorted array arranged in ascending order. HeapSort algorithm has a time complexity of big omega n log n.